A very impressive line of showers and thunderstorms is moving through the deep south this morning. We already had tornado warnings, severe thunderstorm warnings. You can see the higher, colder cloud tops here going through eastern Mississippi now, moving into Alabama with these deep reds indicating some really intense updrafts, even back into parts of Texas here. So be careful this morning. And we have multiple days of severe weather upcoming, and this video is going to forecast specifically on today's threat, and I'll try to make some other videos for subsequent days. That way, you don't have to sit here and listen to all the videos all at once. There'll be timestamps in the video here. Also, I'd appreciate if you like and subscribe. And I want to give a shout out to Mitch West, my friend. He gave a shout out to me in his live feed yesterday, and that's really appreciated, brother. Appreciate that. Love you, man. And so let's get started with today's forecast. So as we start the period, we have severe storms ongoing here in the deep south. You can see very intense line of storms pushing to the east into Alabama this morning. And we had some tornado warnings this morning. You can see some rotation evident from what I can see in this line, right? And down to the south and the parts of Louisiana as well. Some supercells out here to the west, one back in the Texas here as well. See if there's anything else going on. Looks like the supercells all by itself out here, moving out to the south and east. So quite active even into the morning hours today. So as far as today's severe threat, we have a lot going on here. I mean, this is just today, right? We have a very intense, a chance of very intense storms today, especially the hailstorms, right? But we already have a 30% chance here, level 3 out of 5, centered on the areas that we've had storms already here, parts of Oklahoma, generally from Hugo back towards Seminole, okay? And then we have a larger enhanced risk, which is a level 2 out of 5, right? Well, let me see. This is 4 out of 5. Moderate risk. My bad. Anyway, 4 out of 5, 3 out of 5, 2 out of 5, 1 out of 5. So you get the idea. Enhanced risk going all to Oklahoma City, McKinney, Texas, back towards parts of Arkansas and northern Oklahoma here. A larger slight risk going up to Kansas, into Arkansas, parts of Louisiana, back toward Dallas, Texas, with a larger marginal risk going all the way up to Lincoln, Nebraska, and surrounding areas back down to southern Texas here, just by Del Rio. So, very large area, and a chance for general thunderstorms here everywhere else that we have the light green here. So as I explain this every day, I try to explain the best I can here with this sig intensity risk, coupled with the different colors here, right? So 15% chance is yellow, 5% is the brown, and 2% chance of tornadoes is in the green, right? And the hatched area means anywhere within this hatched area, there's a chance of EF2 or higher, right? That's a reasonable max intensity according to the Storm Prediction Center, okay? But the most spatial coverage is expected to be in this 15% area, generally from Norman, Oklahoma, McKinney, Texas here, back towards parts of western Arkansas. But we also have this hatched area even in the marginal risk, the 2%. So if tornadoes do spin up, they could be strong, right? And outside that area, less chance of a strong tornado, a minor chance of it anyway, but you never know, right? So we look at the wind risk. Okay, so we have this 5% wind risk in the brown, 15% in the yellow, and 30% in the red. So what does that mean? Anywhere within this area, even the 5%, we have a chance of 50 knot winds which equates to 60-mile-per-hour wind gusts, right? With the greatest spatial coverage in the 30% area here, generally from just to the east of Oklahoma City, southeastward towards northwestern Louisiana here, parts of southwestern Arkansas and western Arkansas as well, and parts of northeastern Texas, with a slight risk encompassing it further out here. So this really gets serious here, right? We have the double hatching here, right? This straight line in the middle of this 45% risk, hail risk. So that means anywhere in this magenta area, the expectation is 45% chance of either 2 or 3 inch diameter hail within 25 miles of a given location, right? And you get further out, 30% in the red, and then you have the yellow, slight risk 15%, and the brown 5%. But anywhere in this stippled region here outside of the lined is 2-inch hail. So very damaging. I mean, this 3-inch hail is like huge. It could really hurt you, damage your cars, crops. So I won't be surprised if we have larger hail than that. We'll see what happens, but that's pretty intense as far as hail goes. So we'll be looking at the middle and the lower levels of the atmosphere. That's going to be bringing severe weather to us today. I have the severe weather threat outlined here. All right, and in general, what we see is we look at 500 millibars. Let's look at the mid levels. See our ongoing storm moving out, and we have what looks like maybe some mid-level perturbations moving through the flow here. Not a lot of evidence at 500 millibars, although let me get my pen out here. Maybe some subtle shortwaves moving through the flow here. You see maybe some height falls in general right there. Let me make this a little bit longer duration, some height falls. See the waviness here? That may be convection induced too, but you get the idea, right? Let's zoom out and I can show you the overall picture here. You have this mid-level feature up to the north, and you just have different short waves moving through the flow on the back side off this southern stream, right? So as these short waves move through, they create lift in the atmosphere, and amongst other things, right? Dry line effects and boundaries, all kind of things like that. But anyway, that's what's going on with this mid-level feature just hanging out up here. This southwesterly flow just is pumping different disturbances through the flow here, almost El Nino like at this point, right? And with the warm air from the plains, right, being transported this way at the mid levels, right? We have the EML. Can't really type here, write this. Elevated mixed flare, which puts a cap in the atmosphere here initially, which is dry air aloft, right? Which creates a cap, which prevents thunderstorms from firing right off and just being a messy environment, right? With a flow like it is, that keeps this warm, dry air in the mid levels until the cap breaks. And when the cap breaks, we talk about the cap quite often. You can have explosive storm development, and that's part of what the forecast is focusing on today. In a little more detail with this, what we have eventually here, we have a broad surface low eventually forming here in parts of northern Texas, okay? And that's going to really help to bring these dew points and moisture further to the north, 60, 70-degree dew points streaming up into parts of Oklahoma tonight, right? The low-level jet's going to get cranking here as well. Not overly impressive, but enough. See this intensest southerly flow. The low-level jet can help contribute to helicity in the lower levels, which can bring tornadoes. So you see why we have this focused area here where the low-level jet really gets cranking in the evening hours, okay? So you have the low-level jet getting going here, focused area convection here. So that's part of the puzzle as well. And it's part of the environment, right? We know the dew points are warming up. So moving up to the north here in the highest dew points, move right into this focused area where the low pressure is, right? This is surface-based CAPE, which is a good indication of instability at the lower levels, okay? So pretty intense CAPE levels approaching 4,000 joules per kilogram here, which is a lot any time of the year, but even in the spring, that's a lot, right? And you put the helicity values, what we see with storms, well, not helicity values, 1 hour max, 2 to 5 kilometer updraft helicity greater than 75 meters squared per second squared. So it's just showing rotating storms here. So as we get into the evening hours, convection starts to fire up to the north here. Maybe some elevated supercells, more likely a hail and wind threat. Down closer to the surface cyclone with higher dew points. Multiple severe and potentially tornadic supercells firing here. You see the little black lines. So this is more of an evening and overnight event, right? But right near the surface cyclone and where the dry line tightens up, definitely some really good parameter space. I hate to say it for tornadoes. Significant hail and gusty winds here. So let's look at the shear values here. Take this other stuff off. Ensemble mean. This is a max CAPE. Ensemble max, ensemble min. I think that's kind of overdone, but you see the differences here. So this is the mean. And what the HRF is, it's a consolidation, an average of all the short range cams, okay? So convective allowing models allows you to kind of get an a better idea of the average parameter space here. So pretty intense convection will be firing here as we get into the evening hours. As far as flooding, it looks like we get a flooding potential out back here in Louisiana today. Maybe a couple inches of rain here, so we got to be mindful of that as well with these storms. And we get into tomorrow. This is 24-hour flooding guidance, right? So the most rainfall is expected here in parts of Oklahoma and Kansas and Arkansas and parts of Missouri maybe as well. And we get into Monday, it kind of moves to the south and east here. So we definitely have some flooding concerns here as well with these storms, especially if they go over the same areas over and over again. I gotta tell you guys, this is looking very concerning from a radar perspective, a simulated radar. This is the HRRR, which is a pretty reliable model. It's a high resolution refresh model, rapid refresh. You see these updraft velocities and the reflectivity values on the radar here. They all indicate what looks like supercells forming here, right? And they're all discrete in the evening hours, right? You get about 2100. That's roughly, 6 p.m. Okay, don't hold me to that, but that's roughly what it is. 4, 5, 6. The storms eventually maybe congeal into a line here. Maybe some storms forming on the backside of this. More elevated storms as we get towards the end of this into Sunday morning. But it looks like storms may continue here. That way may lead to flooding threat. But initially, you see this line of storms moving off into the Gulf as well. So we got an intense line of storm moving down here as well. Anyway, timing for today, HRRR, firing these up. Let's look at some other models. NSSL model has a little bit different look here, but I mean, it still shows a bunch of supercells firing. ARW, FE3, and NAM Nest, and we get into the 12-hour models here. A little bit different looks, but pretty impressive overall here in parameter space and timing here. So Real quickly, I'm going to go take a few soundings from another site just to go into a little more detail about that, to really discuss the soundings and what the elevated mix layer is, if you want to stick around for that next. So this is the College of DuPage, and I use this for quite a different, it's got some different tools here where I can pull up soundings, and it's I like the way it looks and helps me with things. So this is the NAM Nest, which is the 3K model resolution, right? And this is Monday afternoon proxy sounding from the models. If we looking at it, there we go. So to start off with, this sounding doesn't, you can see here, all right, we have a cap in place at the lower levels, and which is keeping, and that's your cap, right? Then but you have elevated convection already here, all the way up through the column. And this is 12 hours from this latest model run. So 18Z, which is in the afternoon hours. So I wish this would display in like Central Time or something. But let's go back a few hours. We'll generate new sounding here. Well, there we go. See the cap here early in this, a very stout cap. All right, so let's move on. All right, so here's what we got. Surface-based cape, and this is in the area of interest, okay? Surface-based cape, 4,500 joules per kilogram. Lapse rates, 9.3 C kilometers per kilometer. That is incredible lapse rates, which means to me that you have a lot of it's an incredible amount of just the ability for a parcel to rise. So you see throughout the column, even the surface lapse rate is 6.8, which is way above 6, what it could be, and even further aloft. It's a lot of dry air, which contributes to this lapse rate. But you see the cap has been overcome at this point, right? And the hodograph is curved, although not, that strong of a level jet just yet. But you see low level curvature is already there. And based on, this is the way it just tried to figure out what the possibility tornado is here. EF4 plus in this parameter space. All right, I'm not going to say that's going to happen, but the parameter space is there. Okay, now let's move it on a little further here. So yeah, the parameter space is definitely there for severe, potentially violent tornadoes here, as well as hail, very large hail today as well, 3-inch diameter, due to the dry air aloft here. So the cap gets overcome here, at least according to this, right? Let's look at the RAP real quick. The rapid refresh available model shows the same thing, guys. And the cap is eroded a lot more here. All right, so still very, if you look at both of these, I mean, it tells you could have some really serious weather here. You see the cap is the drier air is a lot further aloft here as well. So just a difference in the soundings here, but you get the idea of the potential here. This is a high ceiling event today, I think, and if the potential is reached, we could really have a problem here. I want y'all to stay safe out there today. I'll try to provide updates when I can. I appreciate y'all watching, and I'm going to put together, if I don't run out of time this morning, a couple more videos for the next couple days. Appreciate it. Have a great day. God bless.